Welcome friends to another episode of the show In Search of Lost River Saraswati. We have Dr. Utpal Bhanja, an oncologist by profession and Indologist by passion with us. In the previous episodes, Dr. Bhanja explained to us the importance of River Saraswati in Vedic scriptures, Mahabharata and Puranas, and how the scriptural descriptions relate to modern day findings. Dr. Bhanja also told us about the opinions of various scholars, both Western and Indian. Let's go to Dr. Bhanja and listen to what he is going to tell us today.
Thank you, Kaushik. Welcome, friends and viewers, to another episode of our topic, In Search of the Lost River Saraswati. As Kaushik mentioned, we will be discussing the scientific evidences in support of Saraswati's existence in the past. There are various disciplines come into play together to make the conclusion of the existence of River Saraswati. So it is actually a multidisciplinary approach and includes remote sensing data from the satellites, geological, geophysical findings, hydrologic data, as well as archaeologic findings. So, on today's episode, we will be discussing the remote sensing, imaging, and data in search of Saraswati.
Thank you, Dr. Bhanja. Before going into the details of the remote sensing data and findings, can you please explain what remote sensing is and how can we find the information we are looking for?
You know, Kaushik, remote sensing is nothing new. It is there in nature from the beginning of time, and we have been using remote sensing for several centuries as well. Say, for example, in a human being, we have 5 sensory organs and 2 of them are remote sensing organs, eye and ear. Say, let's take an example of another animal, bat, which is a nocturnal animal and can navigate in pitch black darkness. It has actually a sonar generating organ, and it generates sonar which is reflected from the object and comes back to them, and they have a receiving organ too, so that they can generate sonar, receive sonar, and understand where the obstacles is, and thus navigate without any difficulty during complete darkness. Let's define what is remote sensing. Remote sensing is an art, a science, and a technology adapted for obtaining reliable information of the objects on the surface of Earth without coming into physical contact. In fact, we are measuring and recording the electromagnetic radiations reflected and emitted by the bodies. The objective is to analyze and understand the environment and obtain information on natural resources. The term remote sensing is new, as I told you, but we have been using remote sensing technology, say for example, several centuries ago when Galileo was looking at the moon with his newly invented telescope. He was remote sensing the moon. Later, during the World War, the remote sensing had been used extensively, and the invention of radar was a product during the World War, which is actually a remote sensing as well. The term remote sensing was first used in the United States in 1950s by Miss Evelyn Pruitt of the US Office of Naval Research, and is now commonly used to describe this science and art of identifying, observing, and measuring an object without coming into direct contact with it. As I told you, natural remote sensing organs, the number 1 is eye, which senses the reflected sunlight or the artificial light from the object, and the electrical signal is sent to the brain where it is processed into a visible image. The artificial remote sensing is a satellite which is sensing, has a sensor and receiving the radiation reflected from the earth, sending the data to a ground-based center and then analyzed in the computer. The result is a analyzable data or image. The components of remote sensing include the energy source, which in most cases is the sun, the radiation from the sun in different wavelengths, which I'll talk a little later, interaction of the radiation in the atmosphere, interaction of the radiation at the target area, then the reflected radiation from the Earth object would be sent to the sensor in the satellite. From there, the data will be sent to a ground-based acquisition center, and then in the computer, the interpretation and analysis will undergo, and a analyzable, visible image will appear. So the remote sensing process include an energy source, the interaction in the atmosphere, interaction at the target location, then sensing by the energy detector in the remote sensor, transmission of the data to the ground-based acquisition center, and then data processing in the computer, and then interpretation and analysis resulting in a visible image. Electromagnetic spectrum is the electromagnetic waves starting from gamma rays, X-rays on one hand, where they are very high frequency waves, to on the other hand to infrared, microwave and radio waves, which are low frequency waves. The visible light is in between and is very small, occupies a very small fraction in the electromagnetic spectrum. There are two types of sensors. Active sensors, where the apparatus itself generates its energy and sends it. It works like a flash of a camera. It works day and night like a radar or LiDAR, LiDAR. And the passive sensor is where there is no energy source in the sensor, and it uses the reflected energy from the sun or an outside fire, and it can work only during the daytime when the sunlight is available, like LATSAT, LISS, SPOT, etc. These satellites. There are two types of remote sensing platform. One is called geostationary platform, which is an equatorial orbit, and the satellite moves around the Earth at the equator in a east-west direction, and the rotation of the satellite is synchronized to the diurnal rotation of the Earth, so that it appears the satellite to be fixed in over one location on the Earth, called geosynchronous or geostationary platform. The other is a polar orbit, where the satellite orbits the Earth in a north-south direction and rotates around the Earth, and the rotation is such that it comes to the same location on the Earth at the same time of the day, so that it is also called sun synchronous platform. There are different types of remote sensing depending on the energy source, of course, which is an electromagnetic radiation. If it is optical, using the light, X-rays, infrared or thermal radiation, microwave radiation, depending upon the type of sensor, whether it's an active sensor or a passive sensor, and depending upon the platform, a ground-based platform or a airborne or a spaceborne platform. And spaceborne platforms can be geostationary or could be sun synchronous. Let's understand another term, a technical term. Spectral reflectance curve is a plot between a spectral reflectance, which is a ratio of reflected energy to incident energy, and the wavelength. And it depends upon the chemical composition of the object that it is reflected from and physical conditions. So there would be typical spectral reflectance curve for vegetation, for water, for soil, which are we call spectral signature of that object. The basic principle of remote sensing is that each object reflects and emits energy, a particular part of electromagnetic radiation, in a unique way. Therefore, the signatures received from the different objects is always different, and this is called spectral signature. And this is the key for interpretation of remotely sensed object. There is also interaction in the atmosphere and different medium. Say for example, due to the presence of molecular oxygen and ozone layer in the stratosphere, X-rays are not a good medium of sensing. It will not. It is the atmosphere is opaque to X-rays, as well as majority of the ultraviolet rays. The visible window, or called visible light, which is a good radiation for remote sensing. Then the infrared or near infrared windows, and then the microwave windows are also good. Of course, the water and carbon dioxide may be opaque to some of these, and the atmosphere is completely transparent to radio frequencies. That is called radio window, and the charged particles in the atmosphere may cause opacity to the radiation. So we need to find out the atmospheric windows, the spectral resolution, the spatial resolution, the radiometric resolution, and a temporal resolution of the signals. And there is a low resolution, which is panchromatic, a medium resolution, which is multispectral. There are bands from 1 to 20, and high resolution is also called hyperspectral, which is more than 20 bands is used. Let's find out how a healthy leaf, sick leaf, and a dead leaf is differentiated by this remote sensing. The visible light would fall, actually the sunlight, let's say sunlight will fall on the leaf in a healthy leaf, and the red, blue of the two basic colors will be absorbed, the green will be reflected. Also in a live leaf, the near infrared radiation, which is the heat generated by the living body, would be very high, along with the green color. Whereas a sick leaf, the green color will drop and a red color will increase, and near infrared radiation will decrease. And in a dead leaf, the near infrared radiation would completely will be gone, and the green color would be almost gone, and the leaf would be red in color. So that's how the signal from a healthy leaf, sick leaf, and dead leaf is interpreted by the sensors in the remote sensing satellites.
Thank you, Dr. Bhanja. Thank you for explaining how the remote sensing works and how the data is analyzed. Now, can you please tell us how the remote sensing data is used to explain the existence of the River Saraswati?
Yes, Kaushik, I am going to talk about how the remote sensing data from the satellite images have been used to confirm or suggest the existence of Saraswati River. Till the middle of the 19th century, the river was lost. We all know that. From the mid-19th century onwards, several archaeologists, geologists, geographers, and explorers all traced the paleo channels of the Saraswati River system in northwest India and eastern part of the Pakistan. And they have fairly good idea where the Saraswati was, but really the idea of Saraswati took a new flight when the scientific evidence started coming in, particularly the images from the remote sensing satellites. And obviously the first was the Landsat satellite mission by NASA, which was started in 1972, and Landsat 1 was in commission for 6 years, between 1972 and 1978, and surprisingly took several pictures in the northwestern India which showed extensive paleo channels which were brought in to the knowledge of the different researchers and scientists all over the world. Thereafter, of course, French satellite SPOT, SPOT, and European satellite ERSS started pouring data, and then the Indian Space Research Organization, or ISRO, started with the IRS-1C, and we have collected the scientific and credible evidence about the flow, the migration, and decline of Saraswati River in different phases. And it actually corroborates to the description of the Saraswati River in different literature in different chronologic periods, starting from Rig Veda to Yajur Veda to Ramayana and Mahabharata. And that period is between 7000 BC and 2000 BC. I'll show you a picture, actually artist's imagination of Landsat 1 moving around the earth, and I will show you another slide which shows the Landsat legacy, starting from Landsat 1, which was flown into the orbit in 1972, and there are Landsat 1, 2, 3, 4, 5, they are all decommissioned by now, and we have the Landsat 7 and Landsat 8 are working now. Landsat 6 was a failure, and 2021 there would be launch of Landsat 9. I will show you from the 1970s taken by Landsat 1 a satellite imagery of the Ghaggar-Hakra channel. It's hard to describe. You can always see in the image of the map of that area that it is the Indus river basin on the west, Ganga and Jamuna on the east, and actually Sutlej on the west too, along with Indus. And there is a river channel called Ghaggar-Hakra. Northern part is called Ghaggar, the southern part, which is in Pakistan, is called Hakra, is showing in the middle. Another image I will show you, which will show the Kalibangan and Banauli as well as Rakhigari along the map of the Ghaggar-Hakra river, and the drilling site near Kalibangan, where we have obtained the groundwater, which is felt to be aquifers that has accumulated Saraswati water. Again, another image system I will show you is actually a satellite image I will show you with the Luni river system in the middle, in the south between the Indus and Jamuna Gangetic plains. There will be another map to show paleo bed of the Ghaggar and its tributaries in Haryana as determined by satellite imagery, and where the paleo channel shows the contribution from the Jamuna and the Sutlej. This was published by Utpal in 1980. Buried channel systems in Haryana with younger fluvial activity in a limited area through optically stimulated luminescence or OSL, making the date to be between 6000 and 2900 or 2.9 kilo years before present, and it was published by H.S. Saini and B.K. Tandon in 2009. Again, another map of paleo channels in the southwestern Saraswati basin, marked by the darker shades, is the paleo channel of Saraswati. It was published by ISRO, Jodhpur. The satellite image showing the course of Saraswati paleo channels in Haryana, Punjab and Rajasthan and Gujarat is showing as dark blue channels between the Indus on the west in a green color and Ganga and Jamuna on the east in green color. Again, this is the complex paleo channel map as reconstructed from the satellite images. The Saraswati River system is felt to be flowing from in the higher Himalayas or Manasarovar area all the way to Dwarka or in the Ran of Kutch between 6000 and 3000 BC. And again, the paleo channel map is overlapped with the current political map, where the towns are shown in this map along the paleo channels. The Nara river in the south is one of the part of the paleo channel of Vedic Saraswati, and I'll show you an interesting map. This is the paleo channel map and actually map of living Ghaggar-Hakra river, and you can see the yellow dots, which are all Tirtha Khetras along the Ghaggar-Hakra, and you can see how it follows the whole course of Ghaggar-Hakra in the northern part of the Saraswati paleo channel system. And the red dots are the towns and cities. So you can see this interesting finding. I found very interesting that really all the Tirthas along the Saraswati fall along the Ghaggar-Hakra. Okay. There have been several papers published. Instead of going through all the papers, I will make a summary. Actually, it is a summary already made, published by Dr. Hector A. Orengo and Cameron A. Petrie. And they are from the Department of Archaeology and Anthropology, University of Cambridge. The paper was published in Remote Sensing Journal and published on 16 July 2017 edition. So the abstract, you can read here, the paper presents a seasonal, multi-temporal approach to the detection of paleo rivers over large areas based on long-term vegetation dynamics and spectral decomposition techniques. 28 years of Landsat 5 data and a total of 1711 multispectral images have been bulk processed using Google Earth Engine and code editor, as well as in cloud computing infrastructure. And the application of this approach on the Sutlej Jamuna interflow in the northwest India, a core area of the Bronze Age Indus civilization, has enabled the reconstruction of an unsuspectedly complex paleo river network comprising more than 8,000 kilometers of paleo channels. Is it not interesting, Kaushik, that what data have been found from analyzing all these remote sensing data that were analyzed? It is one of the famous papers and very recent paper, 2017. So how this Saraswati River system decayed or declined? Actually, there is a neo-tectonic hypothesis. There are fault lines in the lower Himalayas along the east-west and along the Aravallis along the north-south, and there were smaller fault lines in the Rajasthan area in the Thar Desert area, Thar Desert, where Thar Desert is. And the faults influence the course of Saraswati. That's what is believed by many of the geomorphologists. This map I am taken from Valdia, whose work was based on S. Sinha Roy, A.B. Roy and S.K. Biswas. The course of Saraswati River in the states of Punjab, Haryana and Rajasthan has been clearly highlighted in the Landsat imagery by the vegetation cover thriving on the rich, residual loamy soil along its earlier course. The digital enhancement studies of IRS-1C data in 1995 combined with radar imagery from European remote sensing satellites ERS-1 and 2 identified the subsurface features and recognized the paleo channels beneath the sands of the Thar Desert. So you know, Kaushik, now what is Thar Desert is a dry area used to be a lush green forest and green valley during the Vedic times. Professor Yashpal and B. Sahai also traced the paleo channels of the river through Punjab, Haryana and Rajasthan, and they concluded that the Saraswati drained at the Run of Kutch in Gujarat, and according to their findings, the river disappeared abruptly in a depression in Pakistan, which is also known as Vinashanam, as I told in my earlier talk. And according to their findings, the river disappeared at that location in Pakistan and did not reach the Arabian Sea currently. But the subsequent studies based on IRS-1C satellite data, they identified subsurface features of the Saraswati River in that area and recognized the paleo channels beneath the sand. Professor Jashpal and his colleagues also observed a sudden widening of the Ghaggar River near Patiala, and they argued that the widening of the Ghaggar River near Patiala was possible only if some major tributary had joined it. You know, Kaushik, which tributary joined at that time? It was felt that the Sutlej or Shatadru was draining into Saraswati at that time. And at the present, the map shows the Shatadru or Sutlej swung suddenly westward almost in a 90 degree near Ropar or Rupnagar to join the Indus and its tributaries, deserting its earlier drainage, which was Saraswati. So several geomorphologists attribute this event to neo-tectonism involving the rise of Delhi Hardwar Ridge and uplift in the Aravallis. The satellite imagery as well as detailed mapping also have revealed the network of distributaries at the Saraswati Delta near the Run of Kutch, with extensive graded deposits and the products of Holocene marine regression. I will stop my talk today here. Thank you for your patient listening and see you again in our next episode.